This is Math 112, section 2.6. We're talking about continuity. We'll be doing numbers 1 through 4. So in exercises 1 through 4, say whether the function graph is continuous on the interval from -1 to 3 inclusive. If not, where does it fail to be continuous and why? Talking about these y's. So let's take a look at the first graph. The first graph looks pretty continuous until we get to this part right here. The circle means that f of x doesn't exist at that point, and that's why the answer for this one, for number 1, will be no, because there's a discontinuity when x is equal to 2. Okay? And it's also not defined at x equals 2. Simple, simple. Number 2. Here, someone would be tempted to say that it's discontinuous because of this sharp bend over here. But this sharp bend meets all the requirements. For example, the limit of f of x, this function, it's g of x, as x approaches 2 from the left-hand side, so 2 minus, sorry. Just erase that, make that look better. The limit of g of x as x approaches 2 from the left is also equal to the limit of g of x as x approaches 2 to the right. So there's no discontinuity. However, this is a problem because even though the limits exist, f of x at that f of a at that point, in this case f of 3, f of 3 does not equal the limit of f of x as x approaches 3. So that's why we have a discontinuity. So no, again. Oops. No, because it's discontinuous at x is equal to 3. Let's go to 3. 3, there is no problem. Again, these sharp bends are easy to deal with as long as we apply the limit rule. That is, the left-hand limit does approach the right-hand limit, so you'll see it in both times. It is no problem, and also at the endpoints. So yes, this is continuous. It's continuous from the interval -1 to 3, which is what the question is asking for. And lastly, let's take a look at 4. 4 is going to be interesting because there is no undefined parts of the graph. Every single part of the graph is undefined. However, it will break here at this point that the limit as k of x approaches 1 from the left does not equal the limit of k of x as x approaches 1 from the right. So we are going to have a discontinuity there. So no, there's a discontinuity at x equals 1.